Well, welcome to my workshop on exploring conditional tokens. So I'm Alan. I'm an engineer from Gnosis, and today I'll be taking you through the conditional tokens. The conditional tokens is a contract that exists on the various chains that allow you to create assets out of ERC-20 tokens that conditionally retain its ERC-20 backing value or something. It's a little bit hard to explain, like in a one-liner. I think it'd be easier just to like actually work with it and see how like the mechanics of it work, and like you can think of ways to use it. You can use conditional tokens to construct things like prediction markets or like kind of escrow mechanisms, other things where like a conditional payout is necessary or desired, or however. The conditional tokens are also powerful in the sense that you can combine conditions, and this allows you to create more, I guess, complex assets that pay out given a set of conditions and allow you to do things like combinatorial prediction markets, which are a little bit more in depth. And on that note, you could even implement things along the lines of futarchy or kind of futarchy based mechanisms on the blockchain. So these are things that conditional tokens enable. So yeah, I guess I guess we'll just start actually doing stuff with the conditional tokens. So I will copy a link into chat here. This is just kind of a project that you could clone and onto your local machine and use if you want to follow along. I'm kind of just going to use this as a way to bootstrap a Truffle project that I'll then use to illustrate various aspects of the conditional tokens. So with that, so like once you've gotten this project or however, actually let me push one thing up real quick. This is just to make something easier. Okay, if you grab it right now, it'll be like current. I just added one script to make something a little bit easier. I'll like explain it once we hit that point, but okay, cool. There's a little thing on my screen that was so. To begin, this is a Truffle project that I will be kind of working inside of while I'm talking about conditional tokens. It's really simple. All it does is just it pulls in the conditional tokens from the package where you can find the conditional tokens contract, and it also pulls in one extra thing that would be helpful. So the conditional tokens were written back when Solidity compiler was 0.5, and then some of the newer tools available in the ecosystem now, like for example, Open Zeppelin's Erc-1155 stuff is only available under like 0.6. So and this stuff is just a workaround for getting Truffle to use multiple Solidity compiler versions. Anyway, this stuff is And that's all I'm doing here is just kind of importing some contracts from some packages you could find on npm, and yeah. Anyway, the conditional tokens, you can find them on npm at this location. If you also want to look at some docs for the conditional tokens, there's a documentation page. I'll also paste this in the chat, that you can use to kind of explore on your own. There's kind of pretty complete documentation on the conditional tokens here, but since I'm here live speaking with you, we'll like actually go through it, like doing some development stuff. So the docs, there are a few sections. I'm just going to go straight into the documentation. This is the developer guide. And as you can see, you can also see where the package is here. The package name is under the gnosis.pm scope, and the package name is conditional tokens contracts. You can find it on npm and install it in your Truffle project if you have a node-based Truffle project. So we have this, and we're also using Open Zeppelin here in this workshop today because they've got contracts working with the Erc-1155 standard, which is a multi-token contract standard that the conditional tokens are reliant on. So there's so I'll like go more into detail about what that entails and what ERC-1155 is. How is it different from, you know, the existing ERC-20 or ERC-721 NFTs, and yeah. So this project, like I said, it imports the conditional tokens contract from this package and this other ERC-1155 holder contract from Open Zeppelin's contracts, and we'll get into that a little later. There's also a migration that just deploys the conditional tokens. Pretty simple. We'll see this being used in the Truffle console in a bit, but to start, I'm just going to start up an instance of Ganache, and so I actually have Ganache. I don't have Ganache the GUI version. So like if you're familiar with this, with the GUI version, it spins up a test blockchain, exposes the JSON RPC on HTTP port 7545 and assigns the network ID to be 5777. That's just what happens when you just open up Ganache by default. So if you're doing this at home, you could do that using the visual Ganache, the GUI and all the nice stuff. I don't have that, so I'm just going to use Ganache, the command line interface version of it. So in order to kind of emulate that, I'm just going to give it the port and the ID that is what the GUI version uses. But anyway, it's the same thing. I'm going to spin this up and probably won't look at it ever again. So yeah. Also want to note that I'm using Yarn in this. You don't have to use Yarn. It should work with NPM and NPX. It's whatever you're comfortable with. But but like personally, I like developing with like Truffle localized to each project. Your preference might be different. If you have a global Truffle, that's cool too. You know, it should all work. So, yeah, actually, because I'm doing stuff with two config files, let me just show you these config files real quick. These config files just and change the contracts directory and assign a different compiler to each one of them. That's how we're able to compile different versions of Truffle. So that's what's happening. You have a command that just strings those together right here. Maybe there's a better way of doing this. This is just why I typed up. So yeah. Anyway, we're going to compile these contracts. There's the conditional tokens contract, which is in the gnosis.pm/conditional tokens contracts package. It's just this contract. And there's also the Open Zeppelin stuff. We'll take a look at that later. No worries. I'll just keep this here for reference. There are a number of, I mean, you could see the source of the conditional tokens here. It's not too long, but we'll like keep this around just in case there's something to reference here. I don't anticipate having to reference it, but yeah. By the way, can everyone see the? I wish. Is this like legible, like the console stuff? Should I zoom in a bit? Maybe I can zoom in a bit.
Yeah, you might want to a bit because I think your connection is causing some artifacting.
All right. I think this will hopefully help. Actually, since we're zoomed in, I'm just going to hide some stuff. I know there's a way to hide this. Okay, here we go. Maximize. Yeah, all right, let's go. All right. So this is basically just a console. I'm in Visual Studio Code, but like obviously you can use whatever editor you like. And this is basically just a terminal. It's a glorified terminal, whatever. So so once the contract's compiled, I should have done this as well. So once the contracts are compiled, I'm going to go ahead and migrate them onto a chain that recall I had spun up over here on this other terminal. And yeah, I was trying this out earlier, so that's why it's replacing the conditional tokens, because the address for the conditional tokens existed on a chain of that network ID and the artifact already. If you're doing this at home, you probably will see that it's a new deployment. Anyway, long story short, there's a instance of the conditional tokens on chain now. So we'll go ahead and just launch into the Truffle console so that we can start rappling with the conditional tokens Truffle contract. Oh, yeah, really gotta. So that's the other thing I added was just and because there are two configurations for the different compiler versions, and because none of them are like kind of the expected Truffle config.js config, you gotta supply this config option. Anyway, now we're in the Truffle REPL, and we got the conditional tokens, amongst other, I believe, contracts and things that you could use. So I just pressed tab twice to look at what I can autocomplete to. But for example, we got the conditional tokens. There are a few other contracts here that we'll get to in a bit, but for now, we're going to focus on the conditional tokens. So I tried this out earlier. There's like top level await in this REPL. I don't know how it happens. It's kind of magical, but it's nice. So yeah, I'm going to go ahead and get the instance of the conditional tokens that have been deployed on chain. So the conditional tokens, they kind of have to have a ERC20 token in order to work. So, oh wow. Okay, so actually, in this case, I should probably grab some ERC20 token here as well. Yeah, so like there are a few extra things in here that are kind of useful. There's like the ERC20 thing. So an ERC20 token, if you haven't heard by now, is like kind of the de facto token standard of the Ethereum network. And there's quite a lot that it can do, but the reason why the conditional tokens aren't structured to use ERC20 tokens is because each time you create a conditional token, you want it to have its own balance. And so kind of the issue with using a conditional token in that case would be that would be like if you were to say start with an ERC20 token and then you had to create 5 other ERC20 tokens that help run like kind of a prediction market or something, you would have to deploy 5 new contracts. With the conditional tokens, one of the benefits of using Erc-1155 is instead of deploying 5 new contracts, you can just use kind of the same contract instance as the container for all these different tokens. That's only one of the benefits. There's, let's see. So I'm going to need like kind of a testing token. I just realized one of the things that the conditional tokens assumes is that there are ERC20 tokens out in the wild that are valuable to people. So for example, you might have wrapped ETH, or you might have actually, hold on. I'm just going to get some some canonical ETH over here, because because I don't want to develop another conditional or like another ERC20 token. Let's see. Oh, I guess it's a. So let me just say this: there's a package on the on npm called Canonical Weave that also has some source code for what's it for, like kind of wrapped ETH, and it's just the source code I pulled off of Etherscan, but yeah, let's go and deploy an instance of this actually. So my bad. I just need like some ERC20 token, and wrapped ETH should be just fine. Should be. Let me see if it'll. Oh, cool. Lucky me. All right. So okay, I don't actually want everybody to like have to redo all this, so I'm just going to stage all this other stuff. So okay, if you pull it off of the GitHub right now, it should be fine. But let's go ahead and like deploy wrapped ETH on the network as well. But okay, so like you can also use DAI. You can also use like some other stable coin. You can also use any ERC20 compliant coin really as what's called collateral. So the way conditional tokens work is you send collateral tokens, which are ERC20 tokens, to the conditional tokens contract. And the conditional tokens contract then holds on to it as collateral, and then when a set of conditions has been fulfilled, when certain outcomes occur in the world, oracles report the payout to the conditional tokens contract, and then the conditional tokens that are backed, the conditional tokens that have expressed the outcomes that were kind of reported, that are backed by the collateral sent to the conditional tokens, can then be redeemed for that underlying collateral. It seems like a mouthful. I think it'd be clear to see like the mechanics of it by actually working with it. So here, go ahead and do a console thing again. All right, so my bad. I forgot to actually get an ERC20 token that whoops. If you're wondering why I did that, it's because I am silly, and this line actually assigned the promise of a contract to Weave, and so like I just awaited itself. Well, okay, so we got an instance of the wrapped ether contract in Weave. So let's see, it should have an address on the chain, and we're also going to get an instance of the conditional tokens contract. Let's see. All right. So now we're ready to actually do some stuff with the conditional tokens. So let's see. The first thing that I want to talk about with the conditional tokens is conditions. So what are conditions? So the conditional tokens, has conditions in its names. There's a function on the conditional tokens called prepare condition. And so this function takes 3 arguments. And we'll take a look at them over here real quick. I wonder if there's a way to expand this. Can I hide this? Toggle. I'm pretty sure. Okay, whatever. We don't need that much screen real estate for this, actually. Let's go ahead and look for this. Okay, here we go. So prepare condition on the conditional tokens takes 3 arguments. It takes an address of some account, and this account is called the oracle. This account is actually any account. So like any account can be an oracle. And so this includes, for example, externally owned accounts as well. So like accounts that are just signed by a private key, or it might be some contract where the contract is expected to make a report on the question once it has been resolved. Speaking of the question, the next argument for the prepare condition method is the question ID. This question ID is just an Ethereum word of basically an ID that ties to some real question. Like a way to implement this, for example, would be to have a database where you have a question ID, and if you query the database with this question ID, you get kind of the question metadata, like what is the actual question, or what the outcomes of the question might be, when is it expected to be resolved, things of that nature. Like a database is one example. Like you could also have an IPFS hash, like if you crop out the first bit, assume a hash type, you could use the hash data as the bytes 32 here. That's another example. Maybe the document on IPFS is formatted in a certain way. It's up to your imagination. But anyway, it's supposed to be closely tied to a question that the oracle here is supposed to answer. And finally, there's an outcome slot count. So this is the number of this can roughly be thought of as the number of degrees of freedom the outcome has in some sense. So or it's a little it's the number of positions that you would split to. Okay, that's right now. That probably makes no sense to most of you right now. It's an outcome slot count. Starting out, like as we're talking about, I'm just going to call this basically the number of outcomes for this question. It's a little more complicated than that, but this is a good baseline for like and like oftentimes it will be the number of outcomes for the question. So we'll just leave it at that for now. I'll refine that statement a little bit later. So 3 arguments: the account that is supposed to be Oracle, the question ID, and the outcome slot count. So I'm just going to it's actually going to mess this up a little bit. Yeah, okay. So that we could get some actually good names here. So first, I'm going to talk about like the oracles. Truffle gives you like accounts. So with Ganache, I think we get 10 accounts, and I'm just going to assign one of them to be the oracle. So let's say, I don't know, this one, I guess. The second account. The second account's the oracle. Okay, and question ID is just some bytes 32. So and this will not be the only question that we have. So actually, I'm going to number the questions here. So there's one question, and I'm just going to say the ID for this is 01, I guess. It's really kind of arbitrary. Like I said, you have to define like some scheme to like match question IDs with like actual question data in a reliable way, but we're just going to ignore that part of the for the purposes of this demo. And so like what kind of question are we asking here? If let's say the question I'm going to say question text. Let's say the question we're asking is, who will we pick? Alice, Bob, or Carol? Well, like, and then somehow there's a way of associating this question ID with this question text. There's some way that everybody agrees on or whatever. Doesn't have to be like super complicated, but if this was like set up, and then what I would do with this question is give it 3 outcome slots. So now I have like an oracle, a question ID, and an outcome slot count, and I can prepare a condition. So this is what we'll do here. We'll give it this oracle. We'll give it the first question ID, and we'll give it a outcome slot count of 3. So one thing you might notice is the oracle is the second account, but by default, the transactions are executed from the first account. So what I could do if I wanted the oracle to send this transaction would be to specify a from field over here. But in fact, the oracle doesn't have to be the account making this condition preparation. In reality, any account can make this preparation. So like, for example, this account could the fourth account, since we're starting to count from 0 here. Anyway, if we wait for this to complete, we should get a successful transaction. Like this transaction happened on the chain. And go ahead and show you that it happened over here. The crucial thing is in the logs, you can see this this event being emitted, the condition preparation event, and in fact, I don't know if this does. Yes, it does, I think. 0. Can I do that? Okay, cool. And if you're wondering what the what kind of information you could get from this event, you could get the oracle that we just passed in, which is just a second account. We can get the question ID. I passed in 0x01. I just want to note that because the question ID's type is bytes 32, it's actually left aligned, or so like right padded with zeros out to an Ethereum word size. And the outcome slot count is, well, it's a BN over here, but it's 3. So what I want to focus on is this condition ID. This condition ID is actually the hash of these 3 arguments. And this is what is this is one element of the conditional tokens. In the conditional tokens, you can use the condition ID in order to talk about a condition. And the condition is just defined to be just some question that a oracle is expected to answer in the future sometime. So you have this condition ID that just identifies what this condition is. And in fact, if you're trying to get this condition ID, you could use a method on the conditional tokens. I believe it's condition ID. Yeah, and you can pass in the arguments for prepare condition to get this condition ID. It doesn't even have to exist yet. Oops. Yeah. Not to exist yet, but like as you can see here, you can verify that this condition ID corresponds to we have here, and it's just a hash of these 3 things. So I'm going to go ahead and store this in a variable. Let's call it the first condition. And so we can refer to it easily later, because we will need this ID later in order to actually do things with the conditional tokens. In the meantime, we have this condition ID. It's the ID of a condition that is supposed to be kind of answered by the oracle sometime in the future. So like if you have this oracle sometime in the future, this oracle can make a report in order to make sure that this condition ID is resolved. Once this condition ID is resolved, there's actually a set of payouts that this condition ID obtains. So right now, there isn't a set of payouts. If you want to get the set of payouts, you would have to look at the payout numerators and the payout denominator. So these 2 kind of define like what fraction of collateral slot gets for resolved condition, and I'll get into that. Or like you'll see an instance of this actually play out later. But for now, like if you for example like query the payout numerators for this condition ID. Oh, okay. So yeah. So since there are three payout numerators is actually accessor that allows you to access each payout numerator. Since there are three different outcome slots for this conditional ID, you have to provide an index as the second parameter. So my bad. Yeah, and let me format this as well because it's a little bit. Yeah. So right now the payout numerators, if you go through and look at them, they're zeros, and if you get the denominator, it's also 0. And this is a sign that this condition has not been resolved yet. It's like these payouts have not been set. Once the Oracle makes a report, and I'll show you this a bit later, these payout numerators and this payout denominator will change on the conditional tokens. Another thing I want to note is that you can get the outcome slot count for this condition if you don't have it already off of the contract. So it's the this is just get outcome slot count, and this gives you a outcome slot count of 3. So if you're wondering if a condition has been prepared or not, and you have a condition ID, which you can get, as I mentioned earlier, from using something like get condition ID. Well, in this case, you already know that it's 3 because you passed in 3. But if you just had this, you could get the condition ID's outcome slot count on chain as well. And this also tells you whether or not a condition has been prepared or not. So just a couple of subtleties on that on that note. Okay, so once we're done talking about conditions, there's actually a lot that we'd have to talk about before we actually get to collateralizing WETH. But just so that we have some WETH waiting for us when we're ready to do everything, I'm going to go ahead and wrap some ETH into WETH. And the way you can do that is by depositing some WETH. Give it, I don't know, I think this is how you do it. I'm not sure. I'm going to give it 10 ETH from so I'll just like have the first account convert 10 ETH into 10 WETH, I think. Did I mess up? Expected token. Oh, yes. Yeah, cool beans. Yeah, I forgot closing parentheses. So basically, in order to wrap ETH into WETH, you just send WETH contract your ETH. don't actually do this with most contracts. I think most contracts on Ethereum won't like magically do things with your ETH if you send it them your ETH. So like just be very careful. But like with WETH, that is the case that you actually send it WETH directly, and then it'll just wrap it for you and credit your account with the wrapped ETH. So so this way, could actually see that if I that we now have some WETH here for this first account. Yeah, and trust me, that is actually 10 ETH, but you know, not sure. You could always use this this method. And how many? There must be some magic happening here. I'm not even going to mess with that. Okay. Okay, so yeah, all right. Let's do it this way. Come on. Okay, and then yeah. All right. So you can see it's 10 way or 10 ETH. So what's it? So we got 10 ETH in our first account, or 10 WETH. So just some ERC20. We'll set that aside. We won't work with that for now. Like, forget about this for now. Just keep that tucked in the back of your head. So let's bring back conditions. Conditions are, recall, a question that an assigned oracle will answer in sometime in the future. That's kind of the definition of a condition, and we have a condition, and it's identified by this ID in the conditional tokens. So this condition may be answered by that oracle sometime in the future, where the oracle is this account, and yeah, so we got this condition. How do we use it? And so we use it by a fundamental operation available on the conditional tokens called split position. So split position is like kind of one of the main operations on the conditional tokens, and it's a little bit complicated. And before we can even get to split position, I think there's a few concepts that need to be ironed out. So, but first, what is split position? What are the arguments? Like, what does it even do? Okay, so if you look on the contract, it has let's see, four arguments, and these 4 arguments are kind of a little tricky to grasp. The first one is the collateral token. So that's a little easy. The collateral token is just the ERC20 token that is going to collateralize the positions that are produced from this split position. The parent collection ID is the next argument. This is kind of this is a little bit complicated. I'll skip over this for now, and just say like for the first time we'll like just supply zeros to this, or like empty or like the zeros bytes 32, like just a whole bunch of 0 bytes. The condition ID. So this is just like one of these things. And recall a condition is just some question that an oracle is going to answer. And a thing called partition. And that is a little bit tricky as well. And that's the next thing I kind of want to talk about in detail. Oh, okay. There are actually 5 arguments. And lastly, the amount of collateral or stake to split. So amounts just like kind of a nominal amount of collateral token. Like for example, we had like 10 wrapped ETHs over here, and that's the sort of amount that we could pass in this as this argument. If we're going to split 10 wrapped ETH worth of collateral, then we would put the 10 bajillion thing, like the one with the 19 zeros after it, that amount over in amount. Yeah. So the next thing I want to talk about is a concept called outcome collections. And so this concept ties in pretty closely with the interpretation of partition as well, and why this is even called partition. The language here is a little technical. Let's try to be as precise as possible, but we'll like talk a bit more in detail about this. So in order to talk more in detail about this, we're going to talk about bit arrays. So if you're familiar with binary numbers, and that's just kind of what bit arrays are, or like if you're familiar with bit flags or things like that, those are kind of instances of like what you might use a bit array for. And a bit array is pretty simple. It's just an array of bits. And recall, a bit is just a value that's either 0 or 1, off or on. So the way bit arrays are often implemented inside of programming languages is via integers. So like on modern processors, modern computer processors, you have machine words that are, like, for example, 32 bits or 64 bits mostly nowadays. So like each machine word like is kind of what the processors like super used to working with, what the machine is comfortable with using. And so like with a 64-bit machine, it's comfortable like putting 64-bit values through like various operations. And so like what this means is you can have a number that is represented on the system with bits, and it will only go up to 64 bits. One thing about the Ethereum virtual machine is that it was specified that the Ethereum virtual machine should work with 256-bit words. I think originally it's because a lot of stuff in cryptos 256 bits or 128 bits. And so like kind of in order to make Ethereum kind of machine that's really convenient for crypto stuff, the size of the word has been defined to be 256 bits in Ethereum. So every time I said word size, like what I meant was 256 bits or 32 bytes or however. So the what this means practically is that So say you have a number 10, like here. This is the number 10. In binary, you might express this as a value with the 1 in the 2 slots, 0 in the 4, and 1 in the 8 slot. So this is what 10 looks like in binary. Is 1010, I think, if I didn't get my math wrong. And actually, there's kind of a nice way to check this in JavaScript. And it's that there's these things called binary number literals. So kind of if you put a 0b prefix on a string of ones and zeros, the JavaScript interpreter will actually interpret this which word, I shouldn't say word, interpret this bit of text as a binary number literal. And so kind of this just to illustrate, like this and this are the same in JavaScript. It's kind of a neat thing. We'll rely on this a little bit in order to talk about partitions. One cool thing about this is that it makes it easier to talk about this section because what we'll be working with are kind of sets of outcomes. So recall that sets of outcome slots. So recall that a condition has a number of outcome slots. And so kind of the condition we had already here, condition 1 ID, has 3 outcome slots as defined earlier. And so kind of if we had 3 outcome slots, if we wanted to specify some subset of those 3 outcome slots, we would need 3 bits. So 3 different bits where each bit tells is supposed to represent whether or not one of the outcome slots is in this set. So this is kind of all these subsets of those 3 outcome slots can be represented by numbers with 3 bits. So this would be kind of the empty set, whereas this would be the just the entire set of outcome slots. And then I'm just going to note this convention. The first outcome slot corresponds to kind of the ones place, so kind of the lowest placed bit, and then kind of the second outcome slot corresponds to the second highest bit, and the third one is the highest bit. So kind of think of a correspondence between these bits and whether or not something's in a set or not. And you would be able to kind of define a subset of outcome slots. So the language I guess we settled on using for this is outcome collection. I think yeah, so an outcome collection, we settled on this name because as you'll see a little bit later, the outcome collection is a little bit more than just the subset of outcome slots for a single condition. So so let's say like we're talking about condition 1, and like to recall, the question that's supposed to be associated with this condition is who will we pick, Alice, Bob, or Carol? So kind of you could think of like kind of this pair, like this pair of condition ID and this, for example, this what's called an index set can be used to represent the outcome slot of Alice. So this is just Alice. I wonder if this works. Yeah. Okay. So like kind of this information about like what question are we talking about? Who's going to answer it? And then this this piece of information about what out of these outcomes or outcome slots of what is part of this outcome collection. Like this pair of information gives you like kind of the outcome collection of just Alice as like. And here's another example, I guess. So if you wanted to get a outcome collection of either Bob or Carol, you would like do something like this. So this is either Bob or Carol over here. And as you can see, like one thing you should be aware of is that just Bob would actually give you an index set of 2. So so like you might be tempted to be like, well, just Carol might give you an index set of 3, but that's not the case, because if you look at just Carol, you will get an index set of 4. And this, just like how one might count in binary, is like and basically just look up binary numbers if you're not entirely sure about this, but like writing it out in JavaScript like this should be pretty clear. Like this is Carol's bit. This is Alice's bit. I'm sorry. This is Bob's bit, and like this is Carol's bit. So like kind of if that bit's set, then this is in the outcome collection, and if that bit's not set, then it's not. So kind of this is these two pieces of information kind of define a basic outcome collection, and there's an ID associated with this outcome collection as well. And so in order to get this ID, there's a function that you could call on the conditional tokens. Called get collection ID. Yeah, that one. And this actually takes 3 arguments. The first argument is something called the parent collection ID. And we won't get into that just yet, but this allows you to combine different collections. So for now, we'll just pass it like zeros. So like an equivalent way of doing this, just passing 0x. It's just passing in zeros, like kind of a null parent collection ID, or also I think I call this a root collection ID sometimes. The second argument is the condition ID, and so this is a like kind of what we're specifying here earlier. And then finally, the last argument for this is the index set. So the index set is a set of indices that like kind of map to the outcome slots associated with the condition ID. So, and one more rule about this, generally speaking, we don't use like whole sets or empty sets actually on the contract. Like you could get a collection ID on this, but generally speaking, that collection ID would be useless. What you want is a index set that's neither empty nor full. So kind of somewhere in between. So I guess here we're going to describe a collection ID that is for just Alice. So the way I would maybe describe this is, oh no, collection ID for A for Alice. Okay, so so like once we got this collection ID, just keep that in mind that this is an ID that exists. It has some meaning to the conditional tokens contract. Another thing that we want to do is get the position ID associated with Weave and this collection. So what does that mean? It just means like right now, this collection ID, all it talks about is a question, an oracle that's supposed to answer a question, and some subsets of the question's outcomes. So like basically just it's talking about some outcome in the future as reported by an oracle. But it doesn't talk about what value is attached to it. And so kind of the way you get to the collateralization mechanisms and such is you turn this collection ID into a position ID. So the you can do this with the get position ID method over here, and this method allows you to calculate a position ID, which I think the first argument is the collateral token that you would be collateralizing this position with. In this case, it would be Weave. And the second argument for this get position ID would be the collection ID for A. So I just realized that collection ID for A is a promise. So is it a promise? I'm going to find out in a moment. So if this doesn't work, then hold on. I'm going to do some janky and it should work. Yeah, okay. Yeah, my bad. So I forgot to await this. So I'm just going to await it. Silly me. Yeah. And yeah, this should be fine now. Another thing I want to note. So position ID is an integer. And the reason why it's a uint is because of the 1155 standard. So a brief digression, well, I guess not a brief digression. The ERC 1155 token standard is a standard that allows you to have multiple kind of multiple sorry, I'm having a moment. Yeah, multiple tokens in a single contract. So with the multiple tokens in a single contract, you also have multiple balance sheets. So for each, so you might have like 10 different tokens in the same contract, and each of these tokens would have to keep track of every user's balance. So like there's, in addition to that, there's deeper mappings to how much does each user hold of token 1, how much does each user hold of token 2, etc. And each of these tokens by the Erc-1155 standard gets identified by a uint. So in fact, the position IDs over here are the Erc-1155 IDs for the different tokens, like token IDs for the various conditional tokens that exist on the conditional tokens contract. So kind of this is why the position ID is actually a big int, or I shouldn't say big, actually a uint. So yeah. So this is the uint that is the position ID for Alice, and we'll use that later, but for now, just keep that in mind. And let's see. Oh yeah, so there's an index set. Okay, so let's recap like kind of all the information that's supposed to be encoded inside this position ID for A. Kind of there's the collateral token, and there's also the collection ID. And inside this collection ID, you kind of get the condition ID, and you also get the index set for Alice, which is just a bit set for Alice, like over here. And in fact, inside this condition ID, you can break it down even further. It kind of encodes what Oracle is going to report on the question, kind of the question ID, and the outcome slot count. So like kind of this is all the information that's supposed to get encoded inside this position ID for A. I should say encoded because you can't actually decompress this into that. It's just that all this like kind of gets hashed down into this essentially. It's a little more involved than that, but anyway, so I promise this is going somewhere. The other thing I'm going to look for is a position ID for B or C, or Bob or Carol. And we'll get this in due time. First, let's get the collection ID for Bob or Carol. And so let's see, gotta wait. Nope. I'll like gloss over this parent collection ID argument for now. Pass in a condition ID for the Alice Bob Carol condition, and also a index set that corresponds with Bob or Carol. So this should give me a collection ID for Bob or Carol, and once that's gotten, the position ID for Bob or Carol can be gotten with this stuff. And so this should also be some value that exists. I can't really like easily describe how this is calculated. So I won't. A lot of there's some elliptic curve stuff that goes on here, and then this is just a hash away from this. So that's that in a nutshell. If you want to dig more into it, we're not going into this workshop though. So we got these position IDs, and kind of what we're aiming for finally is to get conditional tokens in these positions. And so the way you do that is you have to split position. So finally, we can actually go ahead and split position. Well, right before we do this, I want to note that you have to collateralize the position with some ERC20, but the way you do that is you'd have to give the conditional tokens contract an allowance. So kind of before you do all this, the account that is splitting the position would have to make a call to the ERC20 token in order to give an allowance to the conditional tokens contract. And say the amounts for the whole 10 ETH that we have. Yeah, I think that's how we do it. And if I recall correctly, it's from kind of the first account. I didn't even have to type that, I think, because by default it should execute transactions from the 0th account. But okay, so this is just an approval. If you're familiar with the ERC20, yeah, you just approve we're saying that the conditional tokens are allowed to spend 10 of my WETH. And rather account 0 is the one doing that. So that's what just happened. Once that allowance has been set, account 0 can then go to the conditional tokens and say, I want to split. And let's take a look at the arguments here. I want to split the collateral token, in this case, WETH. I want to take this WETH and I want to, I want to split position on this WETH. And again, I'm going to ignore this parent collection ID. We've been talking about collection IDs, but I won't deal with this just yet. So given this weave, I want to split it through this condition, or through condition 1. So, and the next argument is kind of the tricky bit. So there's this argument partition. So it's an array of disjoint index sets, and it's a non-trivial partition. Yeah. Okay. Okay. That sounds like really jargony, which it really is quite jargony. So my apologies, but what it means practically is, if you recall that we had these kind of these things that go into outcome collections, that kind of together with this condition define a subset of outcome slots. The partition is just saying, well, we want you to divide up all of the outcome slots and partition them. And the way you specify the partition is by sending in an array of these things. So, for example, if I wanted to partition the outcome slots of Alice, Bob, and Carol into a partition of 2 elements, one element being only Alice, and another element being Bob or Carol, then I would want to pass in these 2 index sets as the partition. And so, like, kind of, you could see that these 2 elements partition kind of those 3 bits. Like, none of the bits are repeated. Like, if they're on in one element, they're not on in any of the other ones. And this is just saying I'm going to split to looking at this condition and this index set, I'm going to split to only Alice. Looking at this condition and this index set, it's Bob or Carol. So kind of these are the collections I'm targeting. There's this whatchamacallit, there's this wrapped ether that is being passed in as the collateral token. And so this collateral token together with an outcome, you can create a position out of. So finally, the last thing that we have as a parameter is an amount. So some amount to split. Here, I'm going to choose the amount of, okay. I'm going to say 7 WETH. So recall that I have 10 WETH in the 0th account, default account, and I want to kind of turn it into, let's say I want to take 7 of those WETH and I want to split it through this condition so that I get 2 conditional tokens, or 7 of 2 conditional tokens. So like for each type of the conditional tokens, I get like 7 WETHs worth, sort of, or 7, I think 7 bajillion. I don't know what 10 to the 18th is. Anyway, so we'll go ahead and like do this split position here, and as you can see, there's a position split, and there's 7 WETH in this position now. So actually, you can't see this because I haven't. All you can see is that there's something that happened, like a position split happened. Also, I want to note there's some other events that occurred during here. in particular, the transfer batch event occurred. And there's actually another event. So like if you look at the raw logs, you can see that there are actually 3 objects, and like 2 of them got parsed. One of these is actually a transfer for the wrapped ether. So unfortunately, Truffle didn't parse that out here in this REPL. I believe if you looked in test, like if you wrote this in a test, Truffle would find it because it has a registry of event hashes. But here, it just managed to parse these 2, which is fine. This, I guess what I want to say is this transfer batch is actually also emitted by the Conditional Tokens contract and is a transfer batch event that is defined inside the Erc-1155 standard. Whereas this position split is very much just a conditional tokens thing, and kind of it. And there are a few things it gives you, like who did the split, and kind of all the arguments that were provided, actually. Since we already know all the arguments and we know that it's account 0 who's like sending it, I won't like look too much into detail on that event. But okay, like what happened? So recall again, we had 10 WETH in the 0th account, and after doing the split, we should have 3 WETH in the 0th account, actually, because what happens is the conditional tokens has taken the 7 WETH in order to collateralize it. So we should see a debit of 7 WETH to get a ending balance of 3 WETH on the sender's account. Recall this was 10, and now I believe it's not 10. I don't know why it didn't work earlier. Let's see if it'll work now. No? Okay, fine. I don't know why this works, so, but whatever. And so let's see, what 3 tills from wait. Yeah, you could, but like it should be 3. It is 3, you know. Cool beans. Another thing, like I mentioned, since the conditional tokens actually took the 7 wrapped ether in that split positions, transaction, the conditional tokens should have a balance of 7 WETH. So if we go ahead and put this here, you can see that there's 7 WETH here instead of 3, and so like okay, but how do I know that it didn't just take my money and then like now I'm down 7 WETH? Like where did my 7 WETH go? What did I get for sending 7 WETH to the conditional tokens contract? Well, you got conditional tokens, and the way you can check that is recall that earlier we had derived the position IDs for WETH under the condition that Alice gets picked. So like that position ID is the position ID for A. We stored that in here. We can use that to query an account's balance in that conditional token. So here, conditional tokens, we have a balance of method. This balance of method is a Erc-1155 method, and it should have two arguments. The first argument, I'm reading this part from the internal code, but like the first argument is like kind of the balance holder. So that would be our account 0. And the second argument would be the position ID. So here, position ID for Alice. Yeah, and I guess to string, and then I also anticipate that we're going to need to. Well, I guess I will need the toString here if that's the case. Yeah, so like anyway, the moral of the story is that it's 7. That's the punchline. Like we got 7 or really like 7 bajillion units, but like it's formatted like ETH and like WEAF is, so we can use this method in order to reformat it in a more readable way. We got 7 worth of this conditional token, and kind of we get a balance of counts 0. Recall that like this is not the only kind of index that we're splitting towards. So this corresponds with the index set of 001 or like 1, but the index set of 6 or 110 is corresponds with kind of the position where you have Bob or Carol being picked. So conditional tokens representing that position we also have, and that there's we also have 7 units of that, and here I'm going to assume there's 18 zeros. I don't want to type that out again. Okay, so that's cool. We got some conditional tokens. It's a little bit kind of like, well, now what? Like, what do you do with this conditional tokens? It seems kind of let's see, how much time we got. So I think like this is about the halfway point. I think we have enough time. So I'll talk about deeper conditions or deeper
8. 8:10. So that would be, I don't know what time zone you're in. That would be 5:10 Pacific.
Oh yeah. Wait, no, you're in. You're on the East Coast.
Oh, so you have until. Wait, what time zone are you in? You're on the page. Just click on the little calendar next to time left, and you'll see your session.
Oh, okay. Okay, I believe that there's an hour and a half left.
Yeah, approximately. I think that's right.
Okay, okay. So we got time. I'm just popping back into the infinite hall of windows. Oh yeah, if somebody wants to like, if you want to interrupt me for like any questions or anything, just let me know.
Yeah, I'll let you know.
I didn't realize I was sitting out here in the dark like so. Let me turn on some lights real quick. Okay, I mean, I don't think anybody's terribly paying attention to that, but Yeah, now I'm not sitting in a dark room, so. Yep. It seems normal. All right, so I need a drink of water. Hold on. That's good. So far we talked about. I should bring up some paint program. Let me. This will do. Okay. How do I? Hold on. I just need some place to draw on. Come on, please. Okay, it's over here. I don't know what's going on. Whatever. Great. Can now see my terrible drawing skills in a moment. Oh god. I should really have this will do. That's fine. So far we got some weave, which I'm going to represent as this squiggly over here. So we got some weave, and we split this to two different positions. So like now we got this palette is absolutely mellow on the eyes. So like kind of we split this to two different positions. There's Alice, and then there's Bob or Carol. And so like kind of this split is associated with Alice, Bob, or Carol and Carol condition. So like there's a so like kind of this split is through this condition, given this other information like about the partition. There's another thing that you could do is you could split through the through a completely different condition that we haven't defined yet. Like maybe in a bit I will define this. Actually, I'll just go ahead and do this since I kind of hinted that I would define this condition. So we have one condition that has like it comes from one of the question IDs. We're gonna have another question. Gonna call this question 2. It's gonna have this ID and same oracle, I guess, just to make things easy. But you could actually define a different oracle for this. So go ahead and prepare this condition. Let's see. So same oracle. So second question, and and we're going to give this condition 2 outcome slots. So each condition has to have at least 2 outcome slots. And this is how it is. Yeah. Yeah. Okay. So I went ahead and prepared this second condition, and this second condition, for example, I could split into another 2. Like I could take some weave and I could split it into a couple of other positions, like and maybe if I want to give each of these outcomes names, I could call this the lower high condition. But anyway, this is just more the same as what we just explored. What I mean when I'm talking about deeper conditions is kind of you don't only have like kind of these conditions, which are what I would call like first like a level 1 conditions, or like or depth 1, or like I don't know, kind of first level conditions. You could kind of go deeper than that. So you have 2 conditions. Once you split through 1 condition, like you could go ahead and split these through a different condition. So like if you split these, you might get like positions that look like this. And so like, okay, so how do you interpret these positions? It's basically these positions pay out in more specific circumstances than these positions. So like, whereas this might pay out if Alice gets picked. This would pay out if Alice gets picked and stonks are low, for example. And this might get picked if Alice, or this might pay out if Alice gets picked and stonks are high. I don't know. Similarly, you could split things like this, and then it would be like something like this. You can get to these positions over here. And like kind of this would be if Bob or Carol gets picked and stonks are low, or this one would be if Bob or Carol gets picked and stonks are high, something like that. So like kind of you could split things to this deeper level. But what I want to note also is that kind of the order of the splits don't matter. So if you were to take this position and split it further into these deeper positions, you would actually arrive at the same positions as you might arrive at here. So like here, if you split this through this condition, you actually do this number here. Where like you split stonks are low to stonks are low and Alice gets picked, and stonks are low and Bob or Carol gets picked. And similarly, these two go like that. Yeah. I'm great at drawing things. Anyway, so that's the sort of thing that's possible with the conditional tokens, having everything as in like one contract as well. That's another thing that has been enabled by the having all the things in a single contract, is like kind of the interchangeability of these splits. And these things just like kind of more naturally express things like combinatorial prediction markets, or like futarchy stuff. Like kind of you have more options when you're trying to move around this landscape of positions than like simply, you're in one tree, and then in order to get to a different tree, you have to like go all the way out and go back in. Well, like here, you could just kind of go laterally or something like that. If that makes any sense. There is a better drawn diagram in the official docs, actually. So so it's under defining positions part. Looks like this. Recall like we have like we have a condition that's like sort of Alice and Bob or Carol. So like so kind of there's a subgraph of this graph that kind of expresses what I was talking about with that crude paint drawing or whatever. But okay, enough about this like theory. Let's actually do this thing. And in order to actually, make a split from here to somewhere deeper, we have to let's see. We have to we have to use the parent collection ID. So the parent collection ID, which is something I kind of just skipped over earlier, is you could see this in the get collection ID method. Yeah, so like it's the first thing over here. You also see it in the split position method, and it's just like kind of what's the collection ID of the position you want to start splitting at. So let's say we're over here in Alice, and then we want to split from Alice to Alice and low and Alice and high or something like that. Or maybe it would be better if I'm referring to this drawing. Like we're over here, and then we want to do this split to Alice and low and Alice and high. So like first we would get the collection ID associated with this position. So that collection ID, conveniently named collection ID for Alice, and instead of like kind of zero and like empty bytes, which we were using earlier as a collection ID, this is now the collection ID, and so that would be a first argument. There's a couple of other arguments over here. The second condition ID. So recall that we were splitting using the first condition ID over here, and like you could think of it roughly as the dashed red lines here corresponding with like kind of the first condition, and here the blue line here is the second condition, and this one is or supposed to represent the second condition, and so basically in order to do this, you just pass in the second condition ID. Thought that I didn't assign it yet, did I? Okay. All right. I know there's a log of it. I'll just get it like this. So let's see, same Oracle. There's a different question ID, and there is 2 outcome slots on this second condition. Okay, and then it's the thing for pairing the condition, and finally, I was in the middle of doing this thing. Yeah, here we go. All right, we good now. So recall the 3 arguments of the get collection ID method, it's that it's a collection ID for, it's the parent collection ID, and it's also a condition that you're splitting through, that you would be splitting through, and then like an index set representing kind of the subset of outcome slots on this other condition you're splitting through that you want to get the collection ID of. Okay, it's a really convoluted way of saying one of these lines. So like we haven't really defined like which so like with this there are two outcome slots. I'm just going to say that this one's low and this one's high. So like the low bit's low and the high bit's high. Should be easy to remember. And so this this collection ID that results from this calculation, where you send in the collection ID for Alice as the parent collection ID, and then like also additionally the other condition along with the index set for like that goes along with that condition in order to define an outcome set of low, just low. That collection ID should be that collection ID should be let's see, and A and low. Well, I mean that should like do some calculation and then give you like one of those collection IDs, and right now you got a collection ID here. It's kind of hard to tell like what exactly that means just yet, but we'll get there. Let's see. While we're at it, let's also get the collection ID for A and high. And so if you do this here and you pass in this, you will get this other collection ID. And if you combine this with the collateral token again, if you take a collection ID and you combine it with backing collateral, in this case, you can think of this whole subgraph as pertaining to WETH. And so like it only talks about like WETH or whatever collateral token you have going on there. You can get a position ID, and then kind of that position ID is the ID of the token that we kind of want to end up with after this split. Okay. So do some more calculations. This is WETH address, and this is this collection ID, and yeah, I'll keep the same naming convention, I guess. And starting to wish I named things a little. It's okay. It's okay. It's whatever. Okay, so we got these position IDs as well. So I guess what I wanted to highlight was that this collection ID, this parent collection ID, is now coming into use. And another thing that we could do with this with this. Or like, okay, so like, but we don't actually have anything in these positions yet. Not until we split position again. So recall that our 0th account has 7 like weaves, or 7 bajillion units of conditional token in the position ID for A, or like the Alice position, and so like if we do a split from this position to these positions, it should debit some amount from this position and credit it to these deeper positions. So we'll go ahead and do exactly that. Let's see. Conditional tokens. So the thing we're doing is split position, and yeah, again, the arguments of split position, since there are 5 of them, I can't completely remember. I guess I could also point out in the docs where you might find them. It's under splitting and merging positions. Actually, I probably should have been doing this all along. Okay, these 5 arguments, the collateral token. So that's just WEAF. See the parent collection ID, which recall last time we passed in kind of 0 bytes for the parent collection ID, and that's supposed to represent, well, when we're splitting directly from collateral. But in this case, we already have collateralized some conditional tokens. We're actually trying to burn some conditional tokens in order to mint some in some deeper positions. So that's what a deeper split does, is it burns conditional tokens and mints them in deeper positions. So here it's not the empty bytes, not this, but instead it's going to be the collection ID for A, for Alice. And so the condition ID we're splitting through now is the second condition, and the partition here would just be 1 and 2 here, because kind of these are the index sets which partition our 2 outcome slots. So like in one set we only have low, and in the other set we only have high. And actually, just a small side note, this is the only possible partition for condition with 2 outcome slots. And finally, okay, so the amount. Recall that we had split 7 ETHs worth of WEAF into the positions for Alice and the positions for Bob or Carol. So like those are 2 positions that we had split to, like kind of think of it as these 2. Yeah. And what we're doing here is taking one of these positions, not both, but like one of them, and splitting it further kind of into this deeper layer of positions that exist. And so the we can pick any amount as long as it's less than or equal to 7 WEAFs worth. Two-way, okay, yeah. Here I'm going to pick, I don't know, about 4. So this seems to have executed just fine. Yeah. And so what this should have done is burnt some 4 ETH worth of like kind of conditional token in this position in order to mint 4 bajillion here and 4 bajillion here, 4 in units of WETH. And in fact, this should not have affected this other position here. So this should still be at 7. And if you take a look over here, you should see that if you just do a query of the balance, in fact, you should see that the account balance of this account at position for A should now be like 3, which it is. For Bobber Carroll, it should still be at 7, and for these deeper positions where it's like A and low, you should have 4 in each of these. A and low and A and high. But I don't know what I'm doing. Okay, let's see. There we go. Yeah, so kind of like these are fine and all. Kind of this by itself doesn't really accomplish much. If anything, it's just like a really seemingly overcomplicated way of storing funds so far. Because if all you have is this, and like you're just kind of putting things into deeper and deeper positions, like how you get collateral back, like how you get your money or whatever. So there are 2 ways actually that you could go from these deeper positions or any level inside of the conditional tokens back up to the collateral level and like get some money back, so to speak. And the ways are that you can let's see, you can merge position. So merge positions is very similar, or like rather I should say it's pretty much the opposite of split position. If you're able to split position to some conditional tokens, then you should be able to merge position back up the like kind of graph over here. And so if you're like trying to undo some of the stuff that you did, for example, you might say, all right, well, I have a balance in A and B or C, which is the case right now. Let's say you wanted to merge these back into collateral, because recall it's possible to go from collateral to these 2 positions, but so like merging them should get you your collateral back at the expense of burning these conditional tokens. And in fact, that is exactly what merging would do in that scenario. And the arguments for merging are merge positions is the exact same as split position. And so conditional tokens, merge positions. Okay, so So in this case, let's say you're trying to merge from these positions, like the positions for Alice and the positions for Bob or Carol. You get the collateral token, which is WETH, since that's what these positions are backed by. And their parent collection ID, since you're merging to the collateral, would be empty, just like the split case. And the condition ID associated with these positions is the first condition, not the second one. It's the Alice, Bob, and Carol condition. And the partition would be consists of the index set for Alice and the index set for Bob or Carol. Finally, the amount. Let's say we want to like kind of merge two of those, 2 WETHs worth back into actual WETH. So recall, like we took 7 of our WETH and we put it into conditional tokens. So we only have 3 WETH right now in that first account. But if we were to merge this, like say 2 WETH back, we would expect to have expect to have 5 WETH. And so if you execute this merge positions, it will like it should work. And then if you take a look at the balance of the first account for A, now it should only be at 1, I believe, and for the other one should be at let's see, it was at 7. If we took 2 out, it would be 5. And in fact, the conditional tokens also transferred 2 WETH back to the message sender. So here you get the WETH balance of the account. You would see that it should be 5. So that's all good. There is a, let's see. So yeah, so we covered kind of splitting. You can split deeper stuff. You can merge, which is basically the inverse operation of splitting. And so like all of this you can undo. So far, it's just this complicated collateralization mechanism that doesn't yet seem to like have any use. So where the actual use comes in of conditional tokens isn't in like just these mechanisms, but the fact that like I mentioned, the conditional tokens are just an Erc-1155 token. And in fact, Erc-1155 is a standard that allows you to transfer tokens. So, like if you can transfer tokens around, then you could kind of transfer stake in the position around, so to speak, and it's from this transferring dynamic where like you can build things like prediction markets or like futarchy or stuff like that. Like this isn't like, of course, like a end-to-end integrated prediction markets solution or like futarchy solution. This is potentially one ingredient that you can use to build DeFi products like that. Oh yeah, okay. Yeah. Okay. So let's talk about transferring, because that's like kind of what underpins. Like, just imagine, for example, a contract that, or it doesn't even have to be a contract. Like, you just have an account that agrees to buy some conditional tokens for this much collateral. So, like, if you have a price set for these, then, like, in some sense, you have a prediction market, as long as somebody's willing to buy and sell. And of course, with the Ethereum blockchain, you could always write your own exchange contracts. There's plenty of there's like many different automated market makers, I think, out there now, that you could think of, conceptualize, and create as contracts. And with Erc-1155, there are a few things that you want to keep in mind while you're transferring these tokens around. So the big thing, in my opinion, is that the only official transfer functions on the ERC-1155 standard, the only ones that are implemented on the conditional tokens, are the safe transfer from and safe batch transfer from functions. And the reason why they're safe is because, or why they're called safe, is because they don't allow you to directly transfer to tokens to a contract unless that transfer is anticipated by the contract. So what does that mean? Okay, so I mentioned earlier that I brought in like kind of this other contract for some help from Open Zeppelin. There's this contract called the ERC-1155 Holder in their library of like kind of, I guess, standards implementations and things of that nature. And this ERC-1155 Holder is just kind of a convenient thing that says, a convenient contract that says, yeah, I'm going to hold some ERC-1155. Like I'm willing to, as a contract, hold ERC-1155. So what exactly does that mean? I think it may be made clear with like an example. So let's pick a conditional token to use transfer around, so we could kind of get a handle. Let's say the position ID for BC. So Bob or Carol conditional tokens. Those conditional tokens, let's say I want to transfer it to another account. So by default, Truffle gives you 10 accounts, I believe, or Ganache gives you 10 accounts, I should say. And the sixth account, account 5, this account's going to be the recipient of today's Bob or Carol airdrop, because account 0 is feeling nice. So how does account 0 go about transferring to account 5 with the safe transfer from function? And so this is pretty simple. If the account is transferring itself, then let's see, transfers. Okay, yeah. Yeah, so like safe transfer from takes 5 arguments. Yes. Okay, so from to position ID, value, and data. So like, let's say from is our account 0, 2 is our lucky winner, accounts 5, And then this is the position we're transferring, is the Bob or Carol position. Let's see. Value, okay. And value is just like amount, is some amount. Going to, I keep using two-way, so I really should bring that into global scope, but I haven't yet. But anyway, let's see. Let's say accounts 5 wins 2 of those. All right. And the last argument is data, and it's just some bytes. The way to interpret data is for transfers between externally owned accounts, which is this example. Data does not mean anything. So the best thing you would probably do is to just leave this field empty here. And the conditional tokens does nothing with this field. It just passes it along to the transfer callback, which I'll explain in a moment. But for now, safe transfer from will give you a transfer from accounts 0 to 5 of Bob or Carol. No problem, as these are both externally owned accounts. There shouldn't be any problem executing this transaction, and it looks like it succeeded. So all good. If we check again what the account balance of position ID for Bob or Carol now, recall that it was 5. Now it should be 3, which it is. And let's see, nobody else really has any of this except for our lucky airdrop recipient here, I guess, who now has 2 of those conditional tokens, 2 in this, 2 stake in that position, however you want to word it. Okay. Another thing I want to note is that this can't be immediately turned into WETH now, because there's not a complete set. Like, recall earlier that we were able to merge conditional tokens for Alice and conditional tokens for Bob or Carol into its underlying collateral. And that's because we had amounts of both to merge into the collateral, or to the higher level in the positions graph or whatever. But in this case, this is impossible, because this is the only position that this account carries any value in. So in some sense, this account would expect to not get any WETH unless Bob or Carol gets picked in this case. In some sense, you could think of it as that was a conditional payment of 2 WETH made to account 5 from account 0 that just occurred with that transfer. Conditional on Bob or Carol getting picked in this case, or yeah. Let's see. So that's all good and well. What I wanted to note about contracts is, let's say you had a contract that, and this is the part that makes this safe transfer from, is that if you were to transfer to a contract that was not expecting to receive conditional tokens, or like Erc-1155s in general, I should say, then that contract would not be able to handle the callback for this safe transfer from, and it would fail this transaction. So to make this concrete, I'm going to try to transfer 2 more of this Bob or Carol token. So we still have enough to transfer. It's just that we're transferring to this contract instead of some account that has no code associated with it. And if you try this transfer from, you'll actually fail. So let's try this, and then actually you see this error here. Says revert. It's unable to do it. And the reason why is because this contract is not designed to take 1155 tokens, in particular conditional tokens. So what you want to do with a contract, it's not to say that contracts can't accept conditional tokens or 1155 tokens or however. So for example, like there's this 1155 holder contract, and this contract, I'm going to create a new instance of this, and I'm going to call this holder. And this contract can actually hold 1155 ERC-1155 tokens. And the reason why is if we take a look at the source of the contract, and so I'm just going to go ahead and find this here. If we take a look at this, we have these two functions on ERC-1155 received and on ERC-1155 batch received. We'll get to this in a moment, but what I want to focus on is here. On ERC-1155 received is a function that is expected to be called if the contract detects that the transfer recipient is a contract. So like if that transfer recipient has non-empty code, if it's like it's got code associated with that address, then it's going to attempt to call this function. And if this function call succeeds, it will, and if this function call returns this magic value, then then the conditional tokens will assume that, you know, everything's okay, you can complete this transfer, and it will complete the transfer. Another thing I want to note is that there is a bytes argument at the end that is actually the data parameter, and the data that gets put over here, whatever data that might be, it's like maybe it's, I don't know, something here. That data also gets passed to this function. So the intent for this is that you can write a contract that would actually react to being sent conditional tokens or any sort of ERC-1155 token, but the way that it might react is if you're writing, for example, an exchange contract and you really wanted to be clever or like efficient or whatever, you could write it so that the way you interact with it, along with sending it some tokens, you might send it some data that describes the transaction you're trying to perform by sending the tokens to this contract. And it could actually react and do some more complex logic than just simply accepting or rejecting the token. Like really anything based on the arguments you would receive here. I can't exactly remember what they are. They're documented somewhere else. You can look it up on the spec too, but like that's what you can do with a contract account. So here, let's try this transfer again, except this time I'm going to send it to the hodler over here. And this transaction should actually succeed because this this contract actually defines this method. So even though the conditional tokens contract will detect that we're sending to a contract, it will call on Erc-1155 received, get the magic value back, which signals that, this transfer is all hunky-dory. Yeah, and so if you check again the balance of this account in that position, you'll only have one. And for the hodler has successfully received this token. Yeah. That's kind of the basics of transferring conditional tokens. So yeah, you can do this with any position ID and it should work. And yeah, that's transferring. Let's see. Okay, so finally, I don't really talk about I haven't really talked about how to implement like an exchange contract, but if you're familiar with how exchange contracts are designed, you could apply like this sort of stuff to them. Generally speaking, transfers are like kind of the basic atoms of building, exchanges and markets and things like that. Is just being able to transfer from one account to another. Let's see. Okay, so the last element of conditional tokens that we should really talk about is the redemption stuff. So I mentioned earlier that merging is one of the ways that you could get collateral out of the conditional tokens once it's been once like collateral has been sent to collateralized positions inside the conditional tokens. The other way is to perform a redemption, and the redemption relies on conditions having been resolved. So let's first do a resolution process. So for all this happens, we have to resolve the condition that we want to redeem on, and so like let's see, we have a method for reporting the results of a condition, and kind of the way you do this is via the report payouts method. And so what are the arguments for the report payouts method? It's a question ID and an array of payouts. All right, so what is that? We'll just have an example here. That should be pretty straightforward, hopefully. And so report payouts, first argument, question ID. So the thing I want to note here is that it is actually not the condition ID. So I know we've been working with condition IDs over like most of the time, and like kind of the question ID was only there at the beginning so far with preparing the condition, but now it comes around full circle at the end when the reports come in. So the question is, like, say, like if you want to report on a question, say the first question, which is about picking Alice, Bob, or Carol, you would pass in the question ID for that question, not the condition ID. And so actually, let me, for illustrative purposes, like pass in something that's not the that is a condition ID, just to show you that it wouldn't work. Let's see. The second argument is an array of payouts. So the payouts array is an array of it's an array of numbers that represent the numerators of the payouts. So,
hi, Alan. Just letting you know that this is a half hour until the end.
Yes, I am aware of this.
Cool.
Thanks. Yeah, so the array of payouts have, let's see. So for the first condition, recall that there are 3 outcome slots. And in general, when you're making reports, you make a report with the same number of payouts as the number of outcome slots. So, so like here, you might have an array with 3 elements. And finally, with report payouts, so like there are a few methods. A lot of the methods depend on who the message sender is, and report payouts is definitely a huge example of that. In fact, the message sender for report payouts has to be the oracle. So, I guess I'm just going to go ahead and like put the oracle here. Recall that this is actually an incorrectly constructed report payouts because the condition ID is wrong. So, or like you shouldn't be supplying the condition ID, you should be supplying the question ID here. So like, yeah, if you try to execute this, it's going to say condition not prepared or found. In fact, it's not going to find the condition unless everything matches up. So like, for example, even if we were to make this correctly, the question ID, if we have the wrong number of payouts, it will also have the same error here. So like condition not prepared or found, again, the reason why is because the contract will see that there are two elements in here and try to find the condition ID of the condition that is reported by Oracle has the correct question ID, but instead of 3 outcome slots has 2 outcome slots. Similarly, if you have this the correct everything, but you have the wrong Oracle, I think probably this is a safe bet for an account I haven't used yet, then it would also not find the condition. So it's only until like all of these parameters are correspond to the condition that report payouts would be successful. So the message sender being the oracle, the question ID being the question ID associated with the condition we want to resolve. All that's left is to talk about the payouts array here. And what happens here is each of these numbers are an unsigned integer. So here I provided 3 unsigned integers of 1s. What would happen is on the contract level, it's going to see that it's given 1s here, and it's going to say, well, I'm going to resolve this as 1, where like each of these outcome slots would receive 1 out of 3 of their nominal value in collateral if it gets redeemed. So the interpretation of this payouts array is exactly is like really closely tied to what the question is and what the result of the question is. So assuming that you have an oracle mechanism that is trustworthy, which this contract does not attempt to solve for. This contract is just you can choose your oracle, but in this case, this oracle should be trustworthy. It's the once that oracle has been set, this is the format that is expected to be expected by the conditional tokens contract. Is this payouts array, and for example, if say like Bob got picked, so like recall that like kind of our first outcome slot's supposed to represent Alice, our second outcome slot's supposed to represent Bob, and our third outcome slot's supposed to represent Carol. If Bob was the one picked, then this would be a perfectly satisfactory payouts array to provide as a report to the conditional tokens. Yeah, so let's say Bob got picked, or at least that's what the oracle believes. Then and then the oracle may send this transaction in order to set that condition where to resolve to like paying out for the Bob outcome slot completely. So like kind of Bob would get 1 out of 1 of all of the payouts. Like I mentioned earlier, this would correspond with like every payout getting 1/3 of their nominal value, and you could even weight it differently. Like say if you passed 1 to 1, you can maybe look at this as Alice. You add up 1 plus 2 plus 1, you get 4. So Alice gets 1/4 of the nominal value in the slot. Bob gets 2 out of 4, or half of everything, and then or half of like the nominal value, and Carol gets 1 out of 4 in this payout array. The like you could think of more complicated questions in like conditional payout resolutions through this. Like maybe you could base this on like a distribution of votes instead, or something. Like this might be like something like that, where you have like I don't know, like 25, 50%, and then 25%, or something like that. All these are possibilities. Actually, let's do this like, I guess, more exotic outlook, where the first slot gets 1/4, the second slot gets 1/2, and the third slot gets 1/4. But keep in mind that oftentimes you'll often see just like especially for things that are representing like 1 out of these outcomes, you might see something like this. So let's say this is what the oracle reports. The condition gets resolved with these payouts for these slots. So the so what can we do with this this. Well, we have here a number of different accounts with different amounts of positions. I think we'll just work with. Actually, let's look at our airdrop recipient real quick. So, like here, our airdrop recipient dude account 5 accounts has like 2 sort of ethers worth of WETH under a condition that Bob or Carol gets picked, and like that's that condition just resolved to I guess something a bit more complicated than Bob, just Bob or just Carol. But the way you can account for this is by kind of adding the payouts for Bob and Carol together. So according to that, just another note, in order to see that, you know, this condition has been resolved, let's go ahead and show you that the payout denominator for this condition is no longer 0. It's actually, recall at the beginning when it was just prepared, it was 0. Now it's 4 because we passed in, or the Oracle passed in 1 to 1 as the resolution. And so if you look at the numerators, you should also see 1, 2, and 1 here. That's all fine and dandy. Anyway, so you can tell that this condition 1 has been resolved, and the way we can turn this stuff into back into WETH is we take a look at this account's balance, and we're like, okay, we have stuff, we can redeem it. How much can we redeem this for? So right now we have like 2 WETHs worth, and it's in the position for Bob, which has a payout of 2 out of 4 associated with it, and Carol, which has a payout of 1 out of 4 associated with it. And this is supposed to represent value if either Bob or Carol gets some payout. And in fact, it's like the sum of them. And so it would be 3/4 of this nominal value. So at this point, it should be possible for accounts 5 to redeem their conditional tokens for 1.5 WETH. And so let's see, 1.5 WETH. Okay, so in order to do this, you use the redeem positions function, and the arguments for redeem positions very similar to split positions and merge positions. There's a couple of differences, which I'll note in a moment. But first, let's pass in the collateral token, which is the WETH address, the parent collection ID, which in this case would be the empty string because we're merging to root. This isn't like a position that's like kind of deep in the position graph, but rather one of these shallower positions. The condition ID, which is this condition, first conditions ID, and then finally index sets. So recall that before this was a parameter partitions, but this is a parameter index sets because you can actually you don't have to have disjoint index sets here. You can pass in this. You can even do this on top of this. So like it's a little hard to see here, so I'm just going to put this over down here. Okay, like if you look over here, you can have overlapping slots over here, and this is totally fine if you're doing redeem positions, which is why this is called index sets and not partition. Because with partition, you're trying to partition these three into disjoint sets, but with here, you're just listing out all the subsets that you want to kind of redeem from. In this case, the only subset we really care about is the Bob or Carol subset. So it would correspond to this index set. Recall that the outcome slots correspond to from the low bits first up to the higher bits. So like this would be Alice's slot, Bob's slot, and then Carol's slot. Okay. It's fine that we're specifying this other stuff here. If the conditional tokens contract doesn't find any balance in these, it won't really do anything. We'll just like, it just won't redeem anything else out of it. Like nothing will happen, but except you might waste some gas. So actually I wouldn't recommend putting this here, but I'll just leave it there, just show you that that's fine. These are the four arguments: the collateral token, the parent collection ID, condition ID, and the index sets that you want to redeem. And if you execute this, if you execute this, and the message sender has to be the redeemer. In this case, we're thinking of redeeming, or account 5 is thinking of redeeming, so they have to be the one to send the message so that the conditional token's like, okay, it's your account. If this transaction gets executed, then the conditional tokens will look at this account's balances in all of these positions associated with doing stuff with these arguments. It's going to look at all those balances and it's going to burn everything in those balances. But in response to that, it will like credit the account with stake in shallower positions, or in this case, directly with the underlying collateral, because this is kind of the last level left before you reach up to the root level. So let's do this thing and redeem some positions. And I have just did a thing, match of undefined. What did I just do? Actually don't know what happened here. Callback trans. Well, I did something, and and I guess the Ruffle didn't quite like it, but I think that's okay. I think we can figure it out. Let's try some stuff. Like, is it parsing everything? Okay, it's not parsing something. Okay. Maybe if I remove await. By the way, I can't see chat, so if somebody happens to be like actually following along and like spots something dumb I did, then yeah, I don't know why that worked, but you know, let's go with it. So yeah, so like this transaction went through, looks fine to me. All right, cool. And so from after this transaction, we expect that the account balance of accounts 5 for Bob or Carol should be zeroed out, which that's the case. More importantly, if we were to look at the amount of WEEF that count has now, balance of, and we should see that this is no longer 0, but rather 1.5. Yeah, so this is, I think that's really it. Like as far as the conditional tokens contract goes, as far as using it goes, yeah, there are a few more things. There are a couple of things I haven't talked about, like redeeming from a deeper position, which works similar to merging from a deeper position in some ways, except you're actually redeeming, so you have to have a condition that's resolved. Another thing I didn't talk about too much is how like splitting from here might land you at some of the positions that you might get from splitting from there. Another thing I didn't really talk about was, since we're almost out of time, well, those are two main things. Oh, there's one more thing is splitting within the same level. So like if you have Bob or Carol, you can actually split that once more to Bob and Carol by itself. And like merge those as well. So that's the thing you can do. But everything else about the conditional tokens here we've covered in the span of 3 hours, which is just about right for this workshop. Let's see if we got any questions in the last 10 minutes. Oh, hey, Richard. Thanks. I feel bad because I don't know if you're here for the beginning, but I didn't realize that this was happening today. So yeah, this is a little bit off the cuff. Yeah, if you want to play with this, like I mentioned, this is a pretty, I guess, let me push some stuff up real quick, actually, so that it's just slightly easier to use. I think I already did it. Yeah, there's one more little thing that might make this just a little bit better, and that would be to make the migrations not so wordy. So let's go ahead and make it so that you can. And this is actually my first time using multiple configs too. So yeah, I'm going to in this section and like lose everything I was doing up to this point. All right, great. But I think that should work. Well, okay, to be fair, this would be more robust here, and Okay, yeah. If you want to play with this stuff in the way I've been playing with it here, I'll just put this up, and you can find the link here for the supplemental stuff here. And yeah, yeah. Yeah. Yeah, I got the sense that that was going to happen because I don't know. I saw the issue for it and somebody hinted at it. It might have been you, Tyler. So yeah. But for now, that stuff should be play aroundable with. And yeah. Cool. I don't know if there's anything else to say. I was hoping that, given 3 hours, I might get into more advanced stuff. Like I could build a simple exchange contract, but looks like we're out of time. So we'll leave it at this.
Well, Alan, I certainly learned a lot. Thank you very much for doing a 3-hour off-the-cuff workshop.
Yeah, this is actually a first workshop I hosted on this. Oh, thanks, Richard. It's really late in Germany. Okay, so yeah, thanks everybody for watching, and have a nice. Oh, thanks. Yeah. See you later. We'll be around on GitHub. You can also you can message me on the Gnosis Discord. So like actually, how do I Gnosis Discord? I'm sure there's a way to join it. Developer portal, new community Discord. Yeah, okay. Go there, chat. Let's go ahead and copy his link too if you want to reach me. And I think I'm usually pretty good on that. You also like try to grab me on GitHub. If I'm in an issue, you probably can get my attention. Though, like, I do sometimes miss stuff on GitHub. But yeah, I'm around on GitHub too.